So in this video, this is lesson 2 of our probability mini segment here, and we're going to learn about something called an OR probability. And I think the easiest way to understand this is just to jump right in with an example. Normally I do something like this in class and I have people standing up and stuff, and we calculate probability that way. But obviously that's not really an option right now. So instead you have to deal with my sweet drawing right here. First thing I ask for in my probability, and this notation right here, like you see that P parentheses blue, that's just math shorthand for saying the probability you pick blue. So out of all these people right here, if I'm going to pick one of them at random, what is the probability that they're blue? Well, the denominator in probability is just how many options there are, assuming everything is equally likely. And there are 12 people in this picture. So my probability is definitely going to be out of 12. The probability they're blue, I would just count the number of blue people, which is these first 6. So the probability of blue is just 6 out of 12. When you write probabilities, we like to reduce them or make them decimals. Either way is cool. So if you reduce it, it would reduce to a half, or if you were to write that as a decimal, the probability that somebody's blue, if you pick them in this problem, is a 0.5. So then I asked about the probability of green. And with green, we still have 12 people that we're choosing from right here. But this time, there are 3 people who are green right here. So the probability of that is 3 out of 10, or 1/4, or 0.25. So finding a probability really isn't hard when you can see all the options. You just take what you're looking for over the total. Now, the next one is what I'm talking about in this video, or probability. If I want the probability of blue or green, I already found the answer for blue. I already found the answer for green. I can just add those 2 answers together and get my total. So if I look at this, probability of blue, there are 6 out of 12 that are blue. And then if it says the word or, with probability, that means you're supposed to add. So we're combining 2 things. There are 3 of them that are green. And if I add those together, I should get the answer of 9 out of 12, which of course you can reduce 3/4 or 0.75. And if you look at my picture right here, all 5 of these guys are blue, 6, 7, 8, 9. So 9 people out of 12 are blue or green. So it works. You just add them together. I'm going to go ahead and erase this last one here, or give myself a little more space at least. On my 4th problem, I asked for the probability that the person is wearing a hat. Well, if I look at my picture right here, I have 1, 2, 3, 4. There are 5 people wearing hats. So the probability for hats appears to be 5 out of 12. So last probability on this one asks for blue or hats. Well, the probability of blue, we already found. There are 6 blues out of 12. There are 5 hats out of 12. So if I add those up, I am getting myself 11 out of 12, which is great. But if you look at the picture, if I do this in class, I would usually have people stand up now and we'd count. These people would count. They're blue. This guy's blue as well. So that's 6. This guy has a hat. That's 7. This hat and hat, 8 and 9. The 3 people right here that aren't circled don't qualify. So I should have been able to just add the probabilities together, like the last one, blue or green, but it didn't work. It's not 11 out of 12. The reason that it didn't work out, if you haven't already figured it out on your own, is because of this guy right here and this person here. Those people got double counted. They got counted for blue, and they got counted again for hats. So when you add 2 probabilities together, you have to make sure you don't double count. If there's overlap between them, you have to subtract it out. And if I subtract out the 2 people I double counted out of 12, then I do get the right answer for this one of 9 out of 12. So you add your probabilities together, but the new thing that you have to watch out for that trips people up is you subtract out what you double counted, so you don't end up double counting anymore. I have one more example of that. I'll go a little faster through this one. The first one says, what's the probability, I'm picking a number from 1 to 20, that it's prime. Prime means nothing breaks down from it. 1 actually is not considered a prime number. 1 is like its own thing. 2 is prime, 3 is prime, 5, 7, And 10 is not prime, oops. So I have 11, I have 13, 14, 15, 16, 17, and I have 19. So the prime numbers are the ones I have underlined, minus this little smudge right here. And it looks like 1, 2, 3, 4, 5, 6, 7, 8 numbers out of the 20 are going to be prime numbers. Prime numbers are numbers that don't break down in a factor tree. So I got 8 out of 20. Next up, I have factor of 10. Factor of 10 means that the number goes into 10 evenly. So it's numbers that go into 10. So that would be 1. It would also be 2, 5, and 10. Those are the only numbers that go into 10. So there are 4 numbers that are factors of 10 out of 20 numbers on the list. So then I ask you for the big one, what's the probability you're prime? Well, the probability for prime is 8 out of 20. Or, so that means you add a factor of 10. Factor of 10 is 4 out of 20. But anytime you add two probabilities together, you have to ask yourself, did I double count anything? Are there any things that got counted for yellow and for purple? And it turns out, yes, I double counted the number 2. I also double counted the number 5. So what I would need to do to get my final answer is subtract out the 2 numbers that I double counted. And if you do that, you're going to end up with 10 numbers in the list out of 20. So you need to make sure after you add probabilities, just subtract out whatever you double counted. So your assignment for this lesson is going to be to draw me a picture, much like I did with those stick figures earlier on. You're going to make a picture with whatever you want to do. Then you need to make me an OR probability like I did on the last example here or on here. And with those OR probabilities, you need to actually calculate it out for your own problem. So you draw me a picture, you make up your own OR probability where they overlap somehow, and then you just calculate your probability, take a picture of that, and send it my way, and you'll get credit for this lesson.